Hi, my name is Michael Armbrust, and I'm the original creator of Delta, a transactional storage system for storing large amounts of data in the cloud. I'm super excited to be here today with Ryan Blue, the original creator of Apache Iceberg, and we're going to talk about how you can move beyond table formats and start focusing on your data.
As much as I enjoy working in this area, and I'm sure you do too, it's not an area I ever wanted everyone else to have to pay so much attention to.
Yeah, that's right.
It's really good to be working on converging, working on making things just work today, and make it so essentially people don't have to care or pay attention to the format that's beneath their data tables. We never intended for people to, pay attention to this area. It's something we wanted to fix, but people really should not fret over this decision of do I choose Delta or Iceberg. What we really want is for people to, not pay attention and just move on and work with their data.
Yeah, that's right. Storage systems should just work. The whole point is to abstract away problems, not create new ones.
Exactly. Like there should be maybe 20 people in the world that care about this problem, and you should not have one in your organization. So we want you to focus on using your data, not how do I choose what format to use. We've inadvertently created this sort of HD DVD versus Blu-ray type situation where we have two competing formats, and the result of having essentially too much choice is that no one knows which one to back because they want to use the one that's going to win out in the end. And it just means that everyone stays back and continues using the Hive format, which is a huge problem for most organizations.
Yeah, we could both agree that's the worst possible outcome.
Yeah, exactly. And so we needed to figure out some way to actually get beyond that problem. And I think the idea of joining forces and working as a team to come up with one format that's drawing from from the ideas of both and building something better is actually a really great way to solve it.
So why don't you tell me a little bit about yourself and how Apache Iceberg originally got created?
Yeah, sounds good. So I'm Ryan Blue. I originally created Apache Iceberg with my Tabular co-founder, Dan Weeks, while we were working for Netflix. And we were basically running all of the open source data infrastructure there, including our Hadoop clusters, Spark deployments, Trino, and other things. And we ran into, I'm sure, many of the same problems that caused you guys to work on Delta Lake here. How did you see this problem, and what were the specific things you guys were trying to do to solve it?
So we'd been talking for the longest time about building a transactional scalable storage system, and we debated at length like exactly how we were going to do it, where we were going to store the metadata. But the thing that actually led us to create the system and get started was I was at a Spark Summit, which is the old name for our conference. It's now called Data and AI Summit. And I met this really cool engineer, Dominic Brzezinski, who had this massive storage problem. He wanted to ingest all the information, security information for his entire company. Every DHCP request, every TCP request, every DNS, everything, in order to have 100 analysts around the globe kind of query this massive data set in real time, looking for intrusions into their network. And I knew at the time I was leading the structured streaming team, and we were really good at reading data from files, reading data from Kafka, and converting it to Parquet files on S3. But you'd always end up with this kind of success disaster where you have 1 million Parquet files on S3 and all the problems that come along with that. So he told me about this problem, and he said he wanted to kind of start working on it almost immediately. I came back from the summit super energized. I wrote a design doc about, at the time it was called the Tahoe protocol, because Lake Tahoe is a very big lake, and we were trying to create a large data lake at the time. I actually sent the design doc to Ali on a weekend while I was driving up to Tahoe. He looked at it and said, this seems like an important problem. You should just kind of cancel your quarter, reorient the streaming team to work on this problem. And we got started right away. And within 3 months, we were actually testing on their production data. And within 6 months, we had kind of shipped the first version of Tahoe, now Delta.
Wow.
We're actually running their production workload.
Wow, that's impressive. It's amazing to hear prototype in 3 months, 6 months, and then have so much work that has gone into it after that. 5 years worth of work.
Yeah, it was, the first things came really quickly. And then, I think then you learn all the cool things you can do with transactions that took like many years to flesh out.
Yeah, actually, perfecting the merge commands and some of the DML statements and building things to make those efficient. Yeah, there's a lot of depth there.
I imagine you have a very similar story about creating Iceberg at Netflix.
Yeah, we do. So at Netflix, we were always very sensitive to incorrect data or queries that lied to us. This was back before my time, but we had basically been using S3 as our source of truth for a long time. We were one of the first companies to do that. And we just had all sorts of problems because latencies were much higher. So listing operations would come back, very, very slowly. And not only that, you might not get all of the files. So if you have, not all of the files and you're using your file system to keep track of what files are in your table, that's a huge problem. So we had, at our scale, we had just been trying to make the Hive format work for a long time. We built a system for externally consistent listing, basically keeping track of everything that we wrote so that we could tell ourselves what we...
That sounds a lot like Directory Atomic Commit Protocol.
Yeah, pretty much. We were
detour.
trying to do that using, I think, a Dynamo backend across everything. It was called Semper. We'd even gone into our file system implementation and turned off certain checks where we knew we're not going to want to, hit S3 and have a 70 millisecond latency for checking if this thing is a file or a directory. So we're just going to assume it's a file in some cases. And we had accumulated all these things and we looked at this problem and said there are three broad areas where everything is just coming down to Hive not being a good format for database storage. So those were correctness and consistency. Needing to list files from a file system as well as hit a database. There has to be some better way to have a transactional system. Then also performance. So can we get around this listing thousands of directories in order to satisfy a query? And then finally, the usability. And I think that, you guys ran into these problems too, where you can't safely add or delete a column or rename a column. And, the users that are coming from like a Teradata or a Vertica system having to relearn that, you can't rename stuff.
Yeah, that's just table stakes, right?
Exactly. We knew that we needed to, get back to this baseline of, SQL behavior for our tables.
Yeah, so we created these very similar systems to solve these problems, but in doing so, we inadvertently created another problem. Now people have to decide between these two different formats.
And we created this problem where having two, you have to choose which one to use. And now, of course, engines and other frameworks have chosen to support one or not the other. And now we have just a bigger problem of inconsistencies that is preventing people from choosing a modern format at all, which I think is absolutely the worst thing, because that's just a recipe for bad query results and slow performance.
Yeah, because the worst thing you can do is keep your data in the Hive Metastore.
Well, a lot of people still use the Hive Metastore, but yeah, the Hive format is just unsafe,
yes,
right? You're
exactly.
going to get bad results, and no one really likes or expects it when their queries lie to them. It's the same very simple problem. How do we keep track of which files are in our table? And I think we both had the idea of just using existing simple file formats to keep track of that.
Yep.
There are different ways. Delta, I think, notably encodes just the changes to that tree, where Iceberg creates a tree of the data files and metadata. But they're remarkably similar at the core ideas.
Yeah, exactly. Because then, our snapshots look a lot like the Iceberg metadata, because it's just a reconstruction of the changes at some point in time.
Yeah, it's funny how the two have grown much, much closer together over time. I shouldn't say you guys,
Yes.
it's us now. On the Delta side, the field IDs were adopted from Iceberg in order to make table evolution and schema evolution possible. So we're growing much closer together overall. And like you said, the snapshots in Delta look remarkably like Iceberg metadata, and Iceberg is moving towards change-based APIs, like the new REST catalog API is actually change-based in order to get closer and closer to low latency commits.
Yeah, I guess since the architectures are so similar, it's not surprising that we solved a lot of the same problems. They're both ACID transactions. We both have all of these standard DML commands like update, delete, merge that kind of work in very similar ways. And I think it actually is starting to increasingly share implementations inside of Apache Spark.
Yeah, exactly. Yeah, they're almost identical in capabilities at this point as well. I know there are some things at the edges, but in terms of the actual transactional capabilities and ability to act as a real SQL table, which I think is what distinguishes the two formats, that we're really targeting SQL, getting to the usability and performance that people expect with a real SQL database. They're very, very close together. So I think the remaining question was just which one do you choose, how do you choose, and things like that. So I'm glad that we're finally working on that.
Yeah, because you don't want to be picking a format based on these like very subtle differences, like how are timestamps encoded or something like that. That's not useful to your business.
Yeah, exactly. The differences and the two formats did sort of grow apart over time as we solved the same challenges with just different approaches and different ways. But fundamentally, they do the same thing. And that fracturing of, which one should I use, I think is a bigger problem than, the actual problems that we were trying to solve. So I'm glad to see that we're actually moving forward, working together in the communities.
So I think we understand the goal. The goal is we want you to be able to store your data in a fast, efficient, transactional format, and then be able to read it from any engine. Mm-hmm. But what does it actually look like in practice? How do these communities need to move forward in order to realize that vision?
Yeah, I think it goes back to sort of how both formats are designed. At their core, they're both a way of managing a collection of data files. And the metadata layer is much, much smaller than the actual data. So I think the best path forward is to make sure that we're, first of all, curing the inconsistencies at the data layer so that any data file that was written into Delta or any data file that was written into Iceberg is perfectly valid in the other one. We're actually seeing a bunch of technologies or approaches that assume that this is going to be the case. So like server-side planning with the Iceberg REST catalog, or the Uniform project that Databricks released, reusing the data files across both formats. So I think the first step is making all of those inconsistencies go away.
Definitely. And I really like how we're kind of following these principles as we develop new features. So for example, the variant support that both communities are working on. I think we're actually pushing that upstream into Parquet so that there won't be any difference, whether it's a Delta variant or an Iceberg variant.
Yeah, exactly. Both communities looked at the work that was done in Spark and said, hey, that's a really good way of extending both projects. Let's agree on this, actually work together. So people from the Iceberg community are working with people from the Delta community, actually doing this upstream of both in Parquet, so that we have one variant type, making sure that it's a consistent experience across both. So that's a fantastic example of how we're working to make sure those differences go away and you at least have the same data, and then we can move and build on top of that.
So that's a pretty cool vision that we've articulated here, but a lot of customers ask me, where should I put my data today? Like, we've unified some things are not unified. I need to store a bunch of data today. What's the right answer for that?
Yeah, so we didn't magically wave a wand and make this problem go away. So you of course have still these concerns over what works with what. And I think that this is where Unity Catalog really comes in and is going to play an important role. we're seeing the rise of catalogs as a very important way. It's the central point at which you start accessing your data, and so you can make a lot of changes at the catalog layer. And that's certainly our strategy here. It's to use Unity Catalog to make sure that you don't really need to worry about any of these metadata differences in the short term. So what we can do is you can write your data in Delta, you can use your existing pipelines that run in Databricks, but we can use Iceberg metadata as an interchange format, not as the actual storage format, but a way to express what is in the table to other engines. And we can do the same thing with Iceberg, or like I was saying earlier, we're looking at server-side planning and making the APIs work with both table formats. So at the end of the day, the catalog can make this problem go away much more quickly than we can actually get everything to work as a single data format.
That's pretty cool. So if I store my data in Unity Catalog, it'll be fast, efficient, governed, and I can read it from any engine.
That's definitely the idea. And I think governance is really an overlooked area in this catalog space as well. I'm really excited about, essentially, if you look at the history of this space, you had S3, and now we can scale to, essentially multiple engines all running on the same data. Well, Hive wasn't a great format for doing that, so Delta and Iceberg filled that gap and brought us to that next layer. The next thing that needs to be centralized, though, is governance and connectivity, and that's exactly what we want the Unity Catalog to do.
Yeah, I am particularly excited about the catalog. I think one of the things that people liked about Delta was that you could use it directly on top of a storage system, but I really viewed that kind of as a stepping stone to where we're going today. The catalog is what gives you true data independence. It allows you to avoid hard coding paths. It lets you have this unified place to do governance, this unified place to kind of change formats and create the uniform metadata so you can read it from any engine. I think that's a really enabling technology.
Oh, absolutely. Governance was something that we simply overlooked for a number of years, and it's super important. I think almost every company has had this like crash and burn failure of trying to implement their access control policy in file system or S3 permissions.
Yeah, that's right. Directory permissions are not table permissions.
I mean, it all looks great when you get it set up, but in 5 minutes you need to add a group and add some, change roles. And if you're doing that at the granularity of even a prefix in S3, that's incredibly difficult to do. And so what you want is a standard RBAC system where you can model things that match your organization and your actual data.
So we've kind of said this word uniform a whole bunch, but how does that actually solve this problem? What is uniform?
Well, so I think of uniform as a set of technologies. I don't think of it as any one thing. It certainly started as let's take Delta metadata and create Iceberg metadata so that we can give that Iceberg metadata to other readers. But uniform as a broader idea or concept, I think, is really important. It is saying, like, you should not have to care about the data that is in S3. You should leave it to the catalog, leave it to this other layer to make the data compatible with other systems. Whether that is through a common API or whether that is going and rewriting bits in S3, I don't think that really matters. It's more this guarantee that you're going to be able to use your data anywhere it needs to go. I guess this is the catalog, not uniform, but you want that universal governance. You want one set of tables, not to sync data from here or there or sync policy from different catalogs. So a central data plane, central governance, and still be able to use it in Spark or DB-SQL as well as other commercial compute engines.
So it is all based on this idea that like the data is the big thing, and it's all Parquet, and most engines can read Parquet anyway. And now the catalog can kind of translate and speak whatever language it needs to for an engine to understand the metadata of the table.
Yeah, exactly. And metadata representations on disk, those are going to evolve over time. Just like we're fixing the data layer, I think we can. I'm actually really excited about taking the ideas from Delta, the ideas from Iceberg, and converging to something that is actually better than both of them today. and I'm very happy to actually get to work on that. That's a really exciting thing in my day to day. But yeah, we know that that's going to take a few years, that long-term vision of let's converge these things. So it's very important. What can you do today to get past this issue? And I think I really like the idea of we just want to enable you to write in whatever format you're already outputting in your pipeline and have a great experience on that data. We will take care of whatever translation or compatibility is necessary.
Sounds pretty good. That's a pretty cool vision.
Well, it's ambitious, but we're well on the path, so I'm really glad.
So this is all pretty cool, but is any of it real? Can I actually try this out today? What does it mean to use Uniform?
Absolutely. Uniform for Delta tables to expose all of that data to other systems using Iceberg as an interchange format exists today, and you can absolutely go take advantage of it. We have a demo we should show.
Yeah, let's take a look at that.
Hey, welcome everyone. This is Randy Pitcher with Databricks, and I'm going to show you a quick demo of Delta and Uniform working together to share one copy of data across multiple engines. And for that, we're going to use Databricks to create the table and Snowflake to read the table. Let's get right in. So first, let's create a table with some SQL. And to make this a uniform table, we're just going to enable these kind of Delta features. And then from this point on, nothing else that I'm working with has to know about this. And we'll go ahead and insert some data. I have some fake space stuff data that I'm using here that the Databricks assistant helped me to generate and help me with the SQL syntax, so that helps a lot. Great, so we have this. Let's jump over to Snowflake. So with that table, I can actually create an Iceberg table on Snowflake that will read straight from my Unity catalog. It's going to get the metadata there, so I don't have to get my hands messy juggling S3 locations or Azure locations, GCS, anything like that. Let's go ahead and run this. Great, so now we have space stuff. I'll refresh this here, and I would expect a table that we just created just now, that has 10 records. And I'll do a quick preview. There it is. They're all right there. But adding records is easy. Let's do something more interesting. So next, we'll add a column and we'll update some past values. Run this. So this is schema evolution. And then I'm going to do a backfill of false values here, so we can distinguish between actual space objects and maybe fictional ones from our favorite space fiction stories. Let me go ahead and refresh in here. And now I would expect to see a new column. We have is fictional and it's backfilled false. Fantastic. Something to really call out here. This is not a separate copy of the data. It's one copy of the data in your storage locations. You own this data in an open table format, and you're bringing multiple compute engines to your work. Okay, let's do the last one. Let's delete some records. This is always a little tricky. So I'm going to go ahead and delete all of the IDs that are even. So if we have 10 records, 1, 2, 3, 4, all the way up, we would expect to have 5 left. So I'll go back to Snowflake. I will run this command here. And for my last trick, there's 5 rows and they all have odd IDs. This is really just the tip of the iceberg of what I want to talk about, but I'm going to keep it tight right now. Both of these features are fully publicly available. Go check out the docs and try it for yourself. Good luck.
Well, thanks for talking with me today, Ryan. I'm really excited to see what the two communities do together.
Yeah, me too. This was a lot of fun, and I'm super excited to be here working on converging these data formats and making it so people can just forget about data formats and move on to working with their data.